This is oral exam number 2. I will be doing problems 4, 5, and 9. Number 4 states, explain the method you use to factor quadratic expressions, then use your method to factor in each quadratic function. 4a is 3x squared minus 27. For this one, you can use greatest common factor first, and then you will factor after that. The greatest common factor in that one is 3, so it comes out to 3 parentheses x squared minus 9, and then we factor x squared minus 9 into x squared minus 3 squared. This gives us a chance to get our factors for that one, and then the final answer is 3 with factor x minus 3, x plus 3. For our second one, 4b, it is x squared minus 6x minus 16. For this one, since there's no number in A, we just will be using regular factoring, and for this we need to find two numbers that add together to equal b but multiply to get c. So for this one we have negative 6 and then c is negative 16. So what two numbers multiply to get 16 but add up to equal negative 6? So first thing that came to head was 2 and 8, so negative 8 and positive 2 will create negative 16, but it will also create a negative 6 total. For that one, so our two factors would be x minus 8, x plus 2, and we know this because they equal to negative 6 and negative 16 multiplied. 4c is 2x squared minus 5x minus 12. This one we're going to be using grouping because there is a number in the first exponent in A. It is harder to do, and there's not really a number that multiplies into negative 12 with negative 5x. So first off, we're going to be rewrite the middle equation as minus 8x and plus 3x. So instead it is 2x squared minus 8x plus 3x minus 12, sorry. And then we group those two groups, split them in half. And then after you group those two groups, you factor out any common factor in those. And in these ones we found, in the first one, 2x was a common factor, and that left us with x minus 4. And in the other, we have a common factor of 3 that leaves us with x minus 4 as well. So with that one, since we have two x minus 4s, we can just take one of those away, and the other factor would just be 2x plus 3. So our two factors are 2x plus 3 and then x minus 4. And when you do the math for that, it comes out to 2x squared minus 5x minus 12. For number 5, it says, describe what a vertical asymptote is. Explain how to determine the vertical asymptote of a rational function and why this approach works. You must include exceptions to the rule, such as holes. And then C, explain how this discussion can be linked with finding the domain of a rational function. For A, basically, here's the definition. Dictionary definition is, a vertical asymptote is a straight line of the equation toward which a function approaches infinitely close but never reaches the line. So say our vertical asymptote would be 0. A function for that, if you plug in x, it will get incredibly close to 0 from both the negative and positive side, but will never actually touch 0. It would just be a very large decimal and just go on infinitely. Also, for B, to find the vertical asymptote of a rational function, all you really have to do is simply set the denominator equal to 0. This is just getting the math and you solve for x. You're just solving for x with that and make it equal to 0, which is the easiest way possible. This works because the values of x that can't be, this shows us the values of x that x can't be. This doesn't work when your x also makes the numerator 0, because this will create a hole in the equation where both the numerator and denominator is 0. So that is the hole where the line won't touch it. It doesn't even go close to the whole area. How vertical asymptote and domain relate is the zeros of a function are the domain, so we're finding the zeros of the vertical asymptote, and that equals the domain. So say our vertical asymptote would be -3, our domain would be parentheses -infinity, comma -3, u, parentheses -3, comma infinity. So it's just telling us that x can't be -3 at all in the equation, and x affects our domain as well, so that's why they correlate with each other. Number 9 says, explain what a degree is, explain what a radian is, and describe how to convert an angle from degrees to radians and vice versa. For A, basically the definition of a degree is a unit of measure of angles, or 1/360th of the circumference of a circle. So basically it's just 1/360th. It's just a way to measure the degrees of a circle. B, definition of a radian. The dictionary definition is the standard unit of angular measure, and this is the length of an arc of a unit circle is numerically equal to the measurement in radians of the angle that is subtends. So basically, when you have a circle, the radian goes on the arc and equals 1 radian when it equals the length of the radius. So the radian is equal to the length of the radius, but just on the arc of the circle. For C, converting degrees to radians and radians to degrees, basically there's 2 pi radians in 360 degrees of the circle. So to make it easiest, the best math possible, when you have a degrees, say your degrees is 180 degrees, that would be equal to pi radians. But if we're trying to convert to radians, it would be 180 degrees times pi over 180 degrees, and that will give us the number of radians. You can do this with 2 pi radians. I just simplified and took the 2 out and got 180 degrees instead of 360, just to make the math a little bit easier. But basically all you do is have your measure of your angle in degrees, multiply that by pi, and then divide that by 180 degrees, and it should give you radians. And for vice versa, the same way on radians, when you are given radians, you would just simply multiply by 180 and divide by pi, do the opposite. In degrees to radians, we have pi over radians, or pi over degrees, and in this we have degrees over radians. So I just want to restart.